Welcome back, students. We will be looking at section 2.1, practice problems for the addition property of equality. So before we get started, just remember the main thing is to keep our problem balanced on both sides. If we do something to one side, we need to do it to the other side when we're solving for the solution. So let's look at number 1. We have x plus 9 equals 13. I need to get that x by itself, and that's the main goal. So I'm going to do the inverse of what we have with the 9 right now. We have plus 9, but I'm going to subtract 9. If I do it to this side, I need to do this to the other side. So I end up with x plus 0 equals 4, and our answer is x equals 4. Well, when I check that, if I plug the 4 back in, I get 4 plus 9 equals 13, and 13 equals 13. So we did the correct steps. X does in fact equal 4. So think back to when you were finding whether or not a solution was an actual solution to an equation. That was them teaching you how to check your answers, basically. I'm not going to do that for each of these because you already know how to do that. I'm just going to go through and solve them. But when you're doing your own work on homework, quizzes, and tests, I recommend highly that you check your answers. You will catch a lot of errors that way, and it will keep you from putting in the wrong answers and having to do work multiple times. All right, so number 2, I have a minus 6, so that means I'm going to add 6. Remember, we always do the opposite. So I get y plus 0 equals 23. So y equals 23. Well, is 23 minus 6 17? Yes, it is. Let's look at number 3. R plus 4.3 equals negative 5.7. Again, I need to get the r by itself. So I'm going to subtract 4.3 since it was a positive originally. I get r plus 0 equals negative 10.0. So r equals negative 10. All right, this negative 5.7 minus 4.3, if it was written out like this, you would know to do the keep it, change. And if you still need to do that, please do, okay? So that tells me I add them and keep the sign, which was the negative 10.0, okay? All right, let's look at number 4. We have negative 4.6 equals p minus 12.3. So remember before when we had 5 equals y plus, 2, something like that in a previous lesson. And we learned that we could actually switch the problem sides. We're not changing any values. We're not moving what is grouped with what. We're just flipping that whole problem so that we can have the variable on the left side. They equal each other. So again, we're not changing the problem other than we're just flipping it. I'm going to do that with number 4. I'm going to put the p minus 12.3 on the left side and the negative 4.6 on the right side. Same problem, I'm just flipping it. Now I want to move my minus 12.3. So I'm going to add 12.3 to both sides. I get p plus 0 equals, let's see, the difference between those two numbers, because they have different signs, is 7.7. And the 12.3 is the greater number, so it's a positive 7.7. So our answer is, in fact, 7.7. Number 5, we have fractions, but thankfully we have common denominators, so we don't have to worry about that part just yet. Eventually you will have to get common denominators, but just for the simplicity of focusing on the steps, they kept the denominator the same. All right, so I still need to get my x by itself. So I'm going to add 2.3 and add 2.3. So that gives me x plus 0 equals, 5 plus that 2 is going to give me 7, and then keep the denominator. So I have x equals 7/3. Well, 7/3 minus 2/3 is 5/3. So that's the correct answer. Number 6. Now we have basically x's on both sides. So remember, the goal is always to get the x's by itself. But before we can do that, we need to get all of the x's together and then move numbers. So I need to get that 17x with that 18x. I'm going to subtract it. And I'm taking the x with it. All right, so 17x minus 17x is 0, and then I have the plus 6. 18x minus 17x is 1x. And the way I would write that is 6 equals x, and then I would flip it. Because we always want our answer to be on, or our variable to be on the left when we write our answer. So x equals 6. Now you'll notice I didn't keep that 1. 1 is the only number that you wouldn't keep next to the x. It's just understood to be there because we have 1x there. So we don't need that 1 times it. 1 times x is just x. 1 times anything is whatever you were multiplying it times. So that's why we can just remove it and have x equals 6. All right, let's look at number 7. We have negative 6y minus 42 equals negative 5y. Again, we have our variable on both sides of the equation. So we need to get them together. I'm going to add 6y. That's the one I need to move. The negative 5y is already by itself. So I want to move the 6y. So that gives us 0 minus 42 equals 1y. So negative 42 equals y. I'm going to write my answer with my variable on the left. Y equals negative 42. Okay. All right, number 8. Again, we have fractions, but we have common denominators, so we don't have to worry about that part. I'm going to try to get my x's together. So I'm going to minus 2/3 x minus 2/3 x. So that gives me 0 plus 8 equals 3/3 x. Well, 3 divided by 3 is 1. So 8 equals 1x. And my answer is going to be written as x equals 8. So not as bad as it looked. All right, number 9, we have negative 7.6m equals negative 6.6m minus 39. Again, I have variables on both sides, so I need to get them together. I'm going to add the 6.6m, add 6.6m. That gives me a negative 1m equals 0 minus 39. So negative 1m equals negative 39. I cannot leave my m negative. It must be positive. So the way we get rid of a negative is we divide both sides by a negative 1. So m equals 39. Because negative 1 divided by a negative 1 is a positive 1. And then negative 39 divided by a negative 1 is a positive 39. That's our positive negative rules working for us there. Okay, let's scroll up and look at number 10. Number 10 has numbers and variables on both sides. So we're going to add a step here. Same process, we're just adding an extra step. So the first thing I want to do is get my numbers that are constants. They don't have a variable. Get those with each other. And then get my variables together. So the first thing I'm going to move is the 4. I'm going to say minus 4, minus 4. That gives me 0 minus 3x equals negative 4x minus 2. Okay. So think of that one as 2 minus 4 becomes 2 plus -4. We take the difference and keep the sign of the larger. That's how I knew that was a -2. All right, so -3x equals -4x minus 2. Now I need to get my x's together. So I'm going to add 4x, add 4x. That gives me 1x equals 0 minus 2. So x equals -2. All right, moving on to number 11. Again, we have items on both sides, so we need to move our numbers first. So I'm going to subtract my 3. Now notice I'm only subtracting the 3 from the numbers that don't have a variable with it. I can't subtract them from something with a variable because they're not like terms. So I end up with -6q plus 0 equals -7q plus 7. I'm going to rewrite it out. Okay, now I need to get my q's together. I will add 7q, add 7q. That gives me 1q equals 0 plus 7, which is just q equals 7. Number 12. We have -3/7 x plus 8 equals 4/7 x plus 8. So again, we need to deal with the numbers first. So I'm going to subtract 8 from both sides, which interesting enough is going to cancel them on both sides. But that's okay. We can still work with this problem. So that gives us -3/7 x equals 4/7 x. I still need to get my x's together. So I'm going to, add 3/7 x to both sides. So that gives me 0 equals 4 plus 3 is 7. So we have 7/7 x. 7 divided by 7 is a 1. So that gives us 0 equals x. But to write my answer, I'm going to say x equals 0 because we want our variable on the left. Let's look at number 13. The first thing I notice is that I have on the left-hand side some common terms, some like terms. I have 5 and -3. Before I start moving from one side of the equal sign to the other, I want to make sure I combine my like terms. That way I'm not moving any more than I absolutely have to. So I'm going to go ahead and say 5 minus 3 is 2. And then I have the plus 8x, that doesn't change, and keep the 7x minus 6. At this point, I want to move the 2 by subtracting. That's 0 plus 8x equals 7x minus 8. That -6 minus 2 is the same as -6 plus a -2. Remember the keep it change. So if you need to do that to the side, go ahead. I'm going to just go through them like this just for the sake of time. But if you need to go to the side and do that, go ahead. So this becomes 8x equals 7x minus 8. Now I need to move my 7x. So I'm going to subtract 7x minus 7x. So I end up with 1x equals 0 minus 8. So our answer is x equals -8. Number 14. Again, I have some terms that are alike that I need to combine. So 4n minus 8n is -4n. -3 plus 1 is -2. And then rewrite the rest of the problem. I'm going to add 2 to both sides. So negative 4n plus 0 equals negative 5n plus 11. Rewrite that without the 0. Okay, so now I'm going to add the 5n to both sides, add the 5n to both sides. That gives me 1n equals 11, or excuse me, equals 0 plus 11. So n equals 11. Number 15. So again, I notice I have 10b plus 5b, and then I also have 7 minus 4. On the other side, I have 12b plus 2b that can be combined. So 10b plus 5b is 15b. And then I have 7 minus 4, which is 3. 12b plus 2b is going to be 14b. And then plus 3. I will subtract 3 from both sides. That gives me 15b plus 0 equals 14b plus 0. So 15b equals 14b. Now I will get my b's on the same side. I'm going to subtract my 14b minus 14b. That gives me 1b equals 0, or b equals 0, and that's our answer. Okay, let's look at number 16. We have decimals here, which is okay. It doesn't change the steps that we follow. We still follow the same pattern that we've been doing. I'm going to combine my 5.2y and my minus 7.1y. So I get negative 1.9y minus 2.3 equals negative 0.9y minus 1.5. Now I'm going to add 2.3 to both sides. We'll get negative 1.9y plus 0 equals negative 0.9y plus 0.8. Rewrite this. Negative 1.9y equals negative 0.9y plus 0.8. Now I need to add the 0.9y to both sides. I get negative 1y equals 0 plus 0.8. Negative y equals 0.8. I can't leave that y negative, so I need to divide it by a negative 1 and divide the 0.8 by a negative 1. So my answer is actually y equals negative 0.8. Right, number 17, we have fractions. The first thing I noticed is they all have common denominators, so that's good. We don't have to worry about getting common denominators. We can just go ahead and combine like terms. So negative 3 over 7x minus 2 over 7x is the same as saying negative 3 7x plus negative 2 7x. If we do the keep, change, change, I did want to show you this one just so it would be visually helpful. And then I have 2 7x plus 8 minus 4, which is a positive 4 on that side. So negative 3 sevenths plus negative 2 sevenths is going to be a negative 5 sevenths x. Okay. And then I have the plus 8 still equals 2 sevenths x plus 4. I'm going to subtract my 8 from both sides. That gives me negative 5 sevenths x plus 0 equals 2 sevenths x minus 4. Rewrite this just so now we know what we're going to do. So negative 5 sevenths x equals 2 sevenths x minus 4. So I'm going to subtract 2 sevenths x from both sides. That's going to give me, let's see here. I'll go over here just a little bit. I'll erase it in just a second. All right, so that's going to give us negative 7 over 7x equals 0 minus 4. Well, negative 7 over 7 reduces to negative 1x equals negative 4. I can't leave that negative, so I need to divide this by a negative 1, divide that by a negative 1, and our answer is actually x equals 4 for number 17. All right, make sure you get that down. Pause the video, get that down before we move on to number 18. I'm going to erase it, and I want to make sure you actually have that part of the problem down, just because we don't have room, and I need this room for number 18. Okay, so number 18, we now have where we need to use the distributive property. So remember, the distributive property just says whatever is outside, we're going to multiply times whatever is inside the parentheses. So that 2 times that 3 gives us 6v. 2 times a negative 4 gives us a minus 8. And then we have, oh, that's still on the same problem. We have minus 5v equals 7. Now I have 6v minus 5v. That's 1v minus 8 equals 7. So we essentially have v minus 8 equals 7 here. I'm going to add 8 to both sides. V plus 0 equals 15. So v equals 15 is the answer. Now looking at number 19, we have 2 sets of parentheses. Both of these parentheses basically has an invisible 1 outside of it. It's just not written because 1 times anything is just itself, right? So I'm going to stick these in here just to kind of help you see visually what we're doing here. So when we distribute a positive 1 to everything, nothing changes. 1 times 5d is just 5d. 1 times a positive 6 is just plus 6. But when we multiply a negative 1 times something, things do change because of that negative sign. So a negative 1 times a 3 is a minus 3. Negative 1 times 4d is a negative 4d. So it does matter if there's a minus sign out there. So let me draw the arrows so y'all can see what we did. All right, so 5d minus 4d is just 1d. And then 6 minus 3 is 3. Now we need to move that 3 to the other side by subtracting it. So d plus 0 equals 7. So d equals 7. All right, number 20. Again, we're going to distribute. We have that invisible 1 here that will distribute as well. So negative 5 times 3w is negative 15w. Negative 5 times negative 3 is a positive 15. 1 times 16w is 16w. Let me erase that, make that a little bit neater. And then we have 1 times negative 15, which is minus 15. Okay, so we have a negative 15w plus 16w, which is 1w. Then we have 15 minus 15, which is 0. So w equals 0. Number 21. Again, we have distributive property that we need to use. So 2 times negative 3x is negative 6x. 2 times 2 is 4. Negative 5 times x is negative 5x. And then negative 5 times negative 3 is a positive 15. We can now start moving items from side to side. So I'm going to subtract 4 from both sides. That gives me a negative 6x plus 0 equals negative 5x plus 11. Rewrite that. Now I'm going to add 5x to both sides. Get our x's together. I end up with a negative 1x equals 0 plus 11. So negative 1x equals 11. I can't leave it negative, so I'm going to divide by negative 1, divide by negative 1. So x equals negative 11. All right, guys, that's the end of these practice problems. Let's read our verse. The Lord demands accurate scales and balances. He sets the standards for fairness. Proverbs 16:11. Hope you guys are having a great day. I'll see you in the next video. Bye.